Hello. In this video, I'm going to be covering something that has been running around in the back of my mind for the longest time now. And I thought I'd just get it out in front of everybody. What's running around in my mind is regarding DSL modems and one of the possible uses that everybody may be overlooking, and in particular modern DSL modems, DSP based ones like these AR7s, Infineon based AR7s, and the older Texas Instrument based AR7 and AX5, like this one here is an AX5 based DSP based DSL modem, and other manufacturers, which, get this thing out of here, can't really tell what chipset this one's got on it, but it's probably not a DSP based one. And what that possible overlooked application is, oddly enough, is software defined radio. And you may ask, how in the heck can you use a DSL modem as a software defined radio? I'll go over some general stuff that's been running around in the back of my head regarding the AR7 and the other DSP based DSL chipsets. If you look at the basic block diagram, you have the front end, which usually combines a A to D converter and D to A converter that is usually 10-bit or 16-bit resolution, preceded by a low noise amplifier that's either 20 dB gain or 40 dB gain, or somewhere the above, and a final power amplifier for the output channel with a combiner and a final transformer based isolation to the final telephone line. And on the back side of the A to D and D to A converter, it goes to a DSP based, software based DSP processor, which is usually, the code for it is updatable by the firmware that you load into it, into the total unit. And like on the AR7, the DSP core C62 has 6 ALU cores and 2 math cores, which on the AR7 has normal gigaflops rating over 1.some gigaflops, which is pretty good for a couple watt dissipation. A little high level integrated circuit like that. And that DSP core is backed up by a general purpose processor that is connected to the Ethernet, the USB, and the Wi-Fi. And this front end is pretty much limited configurability, but the DSP core and the general purpose core, the software for those is stored on the firmware that you load with the basic operating system for the general purpose core. So pretty much the full functionality of this unit is strictly based on the firmware you load, and that could make this into a relatively powerful software-defined radio with 10 to 16-bit A to D converter resolution, which would give good dynamic range. And not only would it be a good software-defined receiver, the fact that it's got a D to A converter with power output amplifier feeding the telephone line, it can also be used as a software-defined transmitter with the same from what I've seen on some of the spec sheets, but like the AR7 and the other DSL front ends, you have an output that can run up to over 1 watt RMS on the output, so you could have a relatively robust little QRP transmitter, software-defined QRP transmitter, if he is able to get the proper firmware into one of these little devices. And the frequency range of older ones, like the older straight standard DSL standard, usually operated at a max symbol rate or max sampling rate of around 8 million samples per second, which limits the frequency up to around 4 megahertz operatable bandwidth. While the newer DSL 2.0 or plus 2 has a lot of these chipsets have sample rates over 40 million samples per second, so this thing could operate up to 20 megahertz on from zero, well, it's about 150 some kilohertz is the internal low pass filters and the internal high pass filters. From 120 some kilohertz up to about 20 megahertz, one of these units could operate at as a software-defined receiver or transmitter. And the spectral output operating at a transmitter would be better than you'd expect, because most of these DSL front ends use upsampling. They take the, like these, they would take the 8 million samples per second, upsample it several orders, and then run it through a low-pass filter, digital low-pass filter. Then they run it through a to D converter and a D to A converter, running several times the 8 million samples per second, which produces a relatively sparse-free output, even though you're operating a 4 megahertz signal into an 8 mega sample per second D to A converter. Since it's upsampled, you'll have a lot cleaner transmit signal than you'd expect. So that's just what I'm going to throw out to everybody. See what other people come back with as comments about the general idea. But in my own opinion, if people would get to writing the firmware, DSP based firmware and stuff to load into one of these modems, you would have a very, very, very powerful software-defined receiver that can be had relatively cheap, because these old DSL modems are relatively readily available at thrift shops, and people basically giving them away whenever they're upgrading their equipment. So think about it, folks. There's plenty of possibilities out there. Take care.